Hello, hi, this is Achyut. Okay, today we are going to teach the ansys workbench tutorials. Okay, so right now we are going to make a problem in the ansys 14.5 bench. Okay, so let me take it one problem. The problems are already in the help only. So let's go to help and ansys workbench help. In this one on from the ansys incorporation they given some verification manual tutorials. So let me do some verification manual problems only. So in the workbench uh, workbench scripting verification manual. In the verification manual, introduction mechanical, in the mechanical VMM. So today we are going to do this problem. Okay, and we will get results. This is the result we are going to get. So first of all, let us see what is the problem. An assembly of a 3 prismatic box is supported at both end faces and is axially loaded with a forces F1, F2, F1, what is F1? Okay, F1 and F2. So this is the two forces which are given and is applied on the face between the part 2 and the part 3. So this is the places where he applied the forces, and F2 is applied in the face part 1. Apply the advanced mesh control with the element size of the 0.5. Okay, so this is the three prismatic bars, means these three fixed bars which are moving one bar and the other bar. So on the right sides we are fixed. So these bar size are given here, and the material property E value, Poisson's ratio, and density. So this is the force values, and what are the results we are going to get? The finding the reaction forces in the y direction to fixed supports. So right now this is the problem what we are going to do in an answer workbench. So getting to fun. So in the left side answer systems, select the static structural analysis. And double click on the engineering data. Okay, right now we are going to give the material properties data. So this is the property of material. Okay, double click on the engineering data, so you will get a window here. Right now this is the material, he doesn't give any material name, so that we consider the material name as X material. So to add a new material, he had double click on the here and try to give you name as X here. Okay, and the next thing, so right now for X material what are the properties we require the elastic Young's modulus. So that here we have the linear elastic, selective isotropic elastic. Double click on this one. Okay, make double click. So right now it's asking the Young's modulus, and right now he given the Young's modulus in the values in the units of PSI, means pascals per square inch. So that I'm going to change the units into the US customizer, that is LBM inches, so that the values are converted into PSI. So what are the value given? 2.9008 t power 7. Let make it as a select that one and make control copy and go to Young's modulus, paste the value here. Okay, so this is the value what we, this is Young's modulus given. And next one, what is the parameter? Next parameter given for X material, it is Young's modulus. And next one, what is the parameter given? So Poisson's ratio is the 0.3. And next one is the density what given. So pick up the density value. What is the density? So 0.09 lbm per pounds per second. So copy the value and paste the density value. So this is X material which has Young's modulus and the density values. So return to workbench and double click on the geometry to create a geometrical model. Okay, right now this is a one-dimensional problem. We can make the, first of all we can make 3 points. There is a 0.1, 0.2, 0.3, 0.4. Okay, what is the coordinates of 0.1 in 0, 0, and what is the coordinates of 0.2 is 0, that is the X is 0 and Y value is the 4 inches. Okay, let's start the design modeler. So right now the default, if you get to open the ansys modeler, then you get the, it will asking the which are units you require. So the default will require the inches only. Why? Because he given the units are in the 4 inches, 3 inches. So we take it as the inches, as the inches. So right now I'm going to create first point in at origin. So take an origin point in here, and here take it as a manual. Definition is a manual input. So that is the x0 y0 z0 and generate. So right now the coordinate point is created at origin, and pick up the point. Same thing made as second manual input. And what is the second value? In a particular y direction we require a distance of 4 inches. So this is the 4 inches we require. So that I'm going to give the 4 inches in the y direction, so I'm created a second point, and same thing I'm going to create a third point. It has a manual input, and given take as value also y value will be a 3. So what is the third one, fourth one value here? This is the point is a 1 plus 4 plus 3, there is a 7. So my result as a 7 and generate, and take out a new point, make it as to manual input. So what value of a 10. Okay, this is the fourth point, the y direction. 4 plus 3 4 plus 3 7, 7 plus 3 10. Okay, 0 to 4, 4 to 3, 7, 7 to 3 plus 10. So this is the 3 points what we created. Right now we have to make a join between the, we can join a line of these 4 points. So that we created the 4 points. Right now we will make this join. Okay, join a line between these 2 points, create line from points, and pick the on the screen, pick the 2 points which you want. By holding the control button, select the which 2 points you require and hit apply, and it as generate. So that now the line is created between these 2 points. Same thing we repeating the another 2 points. Pick up by holding the control button, select the 2 points and make it as okay concept. Okay, make it as a regenerate generation option, and pick up the line from points, select these 2 point with control, holding the control button, apply. So regenerate. So this is the model what we create. This is the line basic model. And next time right now we have to apply the cross sectional area. What is the cross sectional area? The cross sectional area, which is the 1 into 1, it is a rectangular cross section area. So get into here, concept cross section areas rectangle. So the default will be the breadth will 1 and length will be 1, height is 1. So make it as regenerate. So right now we have to apply this cross section area to that line. So pick up the here line body. In the line body, the cross sectional we had required is a pull down menu, and this is a rectangle one. So generate. Right now we modeled a 3 bimestic bars with the given dimensions. So right now we completed the geometry portion. Close it. And first of all we will save this model. So save. Let me give the name as a VM1, that is a verification manual 1 problem. And next one is, after completing this one you had to do the meshing. So double click on the meshing, that is a model. So let's wait for some time. Okay, so we get a mechanical. This is the main window where we are going to apply the load conditions and we are going to see the results. So pick up on the mesh on the outline tree and make the right click and generate a mesh. Okay, so what he given particularly the element size should be a 0.5 value. Okay, how we can change means the sizing element size to be the 0.5 ratio. Okay, after that, sorry, first of all we should convert into the LBM. So we convert into 0.5 feet. So what are the units given? 0.5 inches. So units convert into inches. Okay, so 0.5 inch. Okay, after giving the element size, make the right click and generate mesh. Okay, so this is the problem here. So right now we want to now apply the fix the model. Where we have to fix the model on the both ends of the three dimensional bars, we have to fix that model. So select the structure and make right click, insert, fixed support. Okay, where you want to fix? First of all, I want to fix at the bottom. Pick up the bottom point. Okay, if it doesn't highlighting this one, pick up in the here you have to select the filters vertex and pick the vertex option and make it as apply. So right now fix it here, and same thing we are going to fix on the top side also. Pick up the top point, apply. So we fix the model at both the ends. And next one is that I want to apply the force at the this point. Okay, so what is the force at the first point? It is a value of 1000 lb in a y direction, 1000 pounds. So pick up the structural, right click, insert, force. Okay, on which point we want? Right now the model is not highlighting, but when you are going to make cursor, then the point will be highlighted. So at what direction right now? Okay, at what direction we want? Right now it's vector, we want to divide into components. So pick up the components. So on vertical y direction I want to apply the 1000 value, that is in minus y. It's showing minus y direction means we are applying as a minus 1000. It means that it is applying the load in a y direction, and it is in a minus y direction. And same thing, structural, right click, insert, and apply the one more force on the second point, apply. And right now you have to choose just the components at what direction, at y direction, value of minus 500. So one is 1000 and second one is the 500. Okay, so this is bound loading and boundary conditions. First of all, we did a model, geometrical model. After that we fixed the model, making mesh model, and that fixed, and we apply the loads. So what are the results we are going to get? It asking that find reaction forces in the y direction. Okay, so we want the reaction forces. Solution, right click, reserve, insert. So what are the results we are going to want? We want the reaction forces reaction. Okay, at boundary conditions of fixed boundary condition, fixed support 1 I require, as well as same thing I wanted the force condition fixed support 2. So at these 2 points I want the reaction forces. So make the solution, make the right click on solution and make it as a solve. Okay, so that the results solved and force reaction. So right now what are the reaction forces we get at the end one? Means the reaction forces are 6000 lb in y direction. So what you asked, find the forces in a y direction at a fixed support. So at fixed point 1 at 600 lb and fixed point 2 it's a value of 9000 lb. So this is the required result what we required. So get it down here. See, y reaction for the top fixed point is the 900. So at the top it's 900 and bottom is the value of 600. So this is the what the results we have to get in a ansys workbench. So we get an accurate results comparing to this ansys, we get the exact results. So it's showing that 9.4, but we are getting accurately 600 maybe. Okay, so this is one of the problem which are given in a verification manual. There is a VM Mech 01 chapter 1. So we completed successfully. If you want to get the this report of this one, so make it as an sorry, I did a mistake, some mistake I forgot it. First of all, we have to apply a material as a X material. So sorry, you have to change the material properties in the geometry line. Here you have to choose as material as X material, and solution same, make it as right click, solve. Sorry, I did the mistake is that I choose this material property as a line one structure still, but I wanted X material. So X for X material also the reaction forces are same thing. For force 2 is also same the reaction force. In previously I didn't choose the material as structure. It is default structure still, but I want to change it to X material. So this is the same result for getting reaction forces. After calculating your model, you want to generate a report regarding this one. Okay, pick on a report view, then you will get a complete report on the what we did previously. So where is the geometrical model? This is your geometry model. And next one is the what is the mesh we did. So with a 0.5 inch element size we did the meshing, and where we fixed the model. So we fixed it at vertex 1, okay, and vertex 2. So what are the force we applied? The force is applied is the one is minus 1000 lb and next one is the minus 5000 lb at vertex 2. So reaction forces, what is the result we're getting? One is 6000 lb and 600 pounds, and next one is the 900 pounds. So this is the result what we get. Thanks for watching tutorials. Can follow me and I'll give you some more tutorials.